min cost climbing stairs. So to solve this problem, we need to know DP, and DP is all about building solutions on top of each other. So to illustrate this example, let's work out a problem that they give us. So we're given the following staircase with the following costs, and the output is 6, but how do we arrive at 6? The core logic here is that you have to understand is to get to subsequent steps, it requires knowing the minimum steps to get to the previous steps. What do I mean by this? Let's consider 1, 100, 1, 1, 1. Just the first 5 staircases for now. Now, to get to the very first staircase, it costs us just 1 because we can start out at index 0 and the same goes for index 1. Now, how do we get to the third staircase? Well, we can achieve that in one of two ways. We can go from 1 to here, or we can go from 100 to here. So what is going to be the minimum of these two possible routes? Well, it's going to be the minimum of 1 and 100 plus the cost of the third step, which is 1, therefore giving us 2. Now, why is this important? This is important because when we get to subsequent steps, this logic recursively builds on top of itself. To get to the fourth staircase, it requires knowing the minimum number of steps to get to either the second or the third staircase added with the cost of the fourth staircase. Because, as you can see, if you want to get to stair 4, we need to get to stair 3 first. If we want to get to stair 3, we have to know how to get to stair 2 and 1 first. So that's the idea. So let's just work out the solution. We can program it up. What is the solution for staircase 4? Well, it's going to be the minimum number of steps needed to get to either steps 2 or 3, which is going to be 102, added with the cost of the fourth staircase, which is going to be 1. Therefore, that's going to be equal to 3. And this makes sense because, again, we can either climb 1 step or 2 steps at any given moment. Therefore, we can get to 4 from staircases 2 or 3. And if you keep on going in this pattern, you will realize that at the very end, the solution will be 6. And to get to the solution, one caveat is that the very topmost staircase, the cost is 0. What do I mean by this? Consider a simpler staircase, 1, 2, 3. We want to traverse all these 3 staircases and get to the 4th position right here. To get to the 4th position, it requires nothing because the only amount of costs that are needed is when we get to the 4th step from the previous steps. So with this logic, we can program it up. We're going to be needing an array that stores the cost to get to each staircase. So let's call that dp. And to declare this array, we're going to say that dp is equal to 0 times the length of cost. And this is because we initialize all the staircases to be cost 0. And we get to basically fill in what the actual costs are as we traverse the loop. So what do we do next? We do for I in range, or actually before we do that, we can first populate the first 2 steps, right? Because the first step would just be the cost of the first step. We can start there. The same goes for the first one. And now we just have to update everything else. So for I in range 2 to the length of the cost, what can we say? We can say that dp of I, meaning the cost to get to the ith step, is equal to the minimum of the cost to get to the 2 prior steps, which is denoted by dpi minus 1 and dpi minus 2, added with the cost of the current staircase. And we return the minimum of dp length of the cost minus 1 and the dp and comma of the length of the cost minus 2. And this makes sense because, again, the dp is going to be of length cost. And from our previous example, we saw that when we get to the uppermost staircase, it's going to be dependent on the prior 2 steps, which at the very uppermost staircase is going to be the length of the cost minus 1 and the length of the cost minus 2. That's the index positions for these 2 steps. So if we run it, it should work. And it works, so let's submit. And there we go. That's the solution.